Hi, good morning students. Yesterday we have gone through the motion of an object which is connected in vertical direction or in horizontal direction, and we have found the tension. I believe that you all practiced that in your home, so it is good for you to practice one or two times, so it will be easy for you. So today we are going to have a new topic that is concurrent forces and Lami's theorem. This Lami's theorem is very important, a 3-mark question. It is very simple one, you can see in page number 129. So first thing, what is meant by concurrent force? What is meant by concurrent? Concurrent or coplanar. All of you know the meaning of the word coplanar. Coplanar means what? Same. So assume that one plane like this. One plane like this. In this plane, some forces acting. 3 forces acting. Okay. This F1, F2, F3. So assume that these 3 forces are acting, 3 lines of forces acting at a common point. That is what? So 3 forces which is acting at a common point, so we can tell it is a same plane. You see, 3 forces which is acting at a common point in a same plane. In one same plane, 3 forces acting. These 3 forces which is acting at a same point. So we can say these are concurrent forces. Or we can say these are what are? It is coplanar forces. Understand? So just nothing. All the forces which is acting in a plane at a same point. So that we can tell it is coplanar forces. Based on this Lami's theorem also based on, suppose if the system, assume that this is a system, okay, F1, F2, F3, or you can go to like textbook F1, F2, F3. Follow the textbook. So F2, F3. Now here alpha, beta, gamma. Okay, so now you see this is a diagram which is given in your textbook. You can follow the same. Then you will not get a confusion. So you see, this is a system. We can say the system is in equilibrium. 3 forces which is acting on a system. If the system is in equilibrium, you see 3 forces. Force 1, force 2, force 3. All is which is acting at a point. Then how we will find the magnitude of each force? That is what? Lami's theorem. So Lamy is saying to find out the magnitude of this each force, that is what his theorem. The magnitude of each force. Suppose you want to find out the magnitude of the force 1. This Lamy is saying force 1 magnitude you are finding means it is equal to the proportion. It is equal to what are? It is directly proportional to the sine of the angle between another 2 forces. That is what Lamy said. This is the angle between these 2 forces, alpha. So if you want to find out the magnitude of F1, it is proportional to the sine of what are? Sine of angle between other 2 forces. So sin alpha. So F1, you want to find out the magnitude for this F1. It is what? What law we said? He said that it is equal to, it is proportional to what? Proportional to the sine of the angle between another two forces. Suppose we are finding F2. F2 means opposite F2 is what? This angle. This angle beta. So magnitude of F2 is proportional to sine of angle between other two forces. So this is the other two forces, sine beta. The same thing F3 you are finding. So magnitude of F3 is proportional to the sine of the angle between other two forces, so sine gamma. This is what Lami's theorem. And this Lami's theorem is used to analyze what? The forces which is acting on the object at equilibrium. For static equilibrium and all, some object which is in static equilibrium and all, and there are some forces acting, means to find out the magnitude of that forces we are using this Lami's theorem. So page number 129 it is there, Lami's theorem. What are the magnitude of each force is proportional to the sine of the angle between other two forces. You have to draw this diagram, you have to write these equations, you have to write the use, then theorem, then you will get a 3 mark. It is very, very important question. Then next topic is very, very important, the law of conservation of angular momentum. Sorry, here linear momentum. Law of conservation of total linear momentum. So, you know, when you are smaller grade, you have learned the law of conservation of energy. Energy cannot be made or destroyed, but it can be changed from one form to another form. That is what we have learned, the conservation of energy. In the meantime, the same thing you see in nature. In nature, this conservation of energy concept is very, very important. In mechanics, 3 conservation we are using. That is what the conservation of energy. First one, this is second one, conservation of total linear momentum. Then the last one is conservation of total angular momentum. So actually, you see, assume that 2 particles interact with each other. So here, this conservation of total linear momentum is finding by combining the Newton's second law and the Newton's third law. You know the Newton's second law. F is equal to ma, or you can use that F is equal to dp by dt. So here we are using dp by dt, momentum. Assume that the 2 particles interact with each other. When these 2 particles interact with each other, 2 particles, assume these 2 chalk, interacting with each other. When these interact with each other, this is particle 1, P1, you can keep P1, this is particle 2, P2. When these 2 particles interact with each other, this particle 1 exerting a force on this particle 2, at the same time this particle 2 exerting a force on this particle 1 which is in the opposite direction. That is what we are using here, Newton's second law. So according to Newton's second law, this is what F21 is equal to minus F12. This is what. So one particle 1 is there, particle 2 is there. This particle, the 2 particle which is interacting with each other. When it is interact with each other, what is happening? This particle exert a force on this particle 2. The same time particle 2 also exerting a force on this particle 1, but in the opposite direction. That's what we are using what are minus symbol. F21 is equal to minus F12. This means what? Force exerted by the second one on where? On the object 1, on particle 1. This is also F12 means what? Force exerted by the particle 1 on 2. Force exerted by the particle on 2, force exerted by the particle 2 on 1. So this is what? F21 is equal to minus F12. We can write in terms of Newton's second law, momentum. In terms of momentum, we can write this equation. So this you keep 1. Now F is equal to dP by dt. Particle 1 dP1 or F is equal to dP2 by dt. This is equation 2 we can keep. Now substitute equation 2 in equation 1. So what will happen? Instead of this F21, you have to apply this one on 2. This is F21 we can keep. Now apply this. So dP2, this one by dt is equal to minus F12 means what? dP1 by dt. So you see F12 force exerted on 2 is dP1 by dt. Force exerted on 2 on 1 is dP2 by dt. Now substituting this on here, so what we will get? dP2 by dt equal to dP1 by dt. So rearrange and write. So what will come? What will come? dP1 by dt is equal to dP2 by dt. So we can write this equation dP1 by dt, here minus symbol is there, plus dP2 by dt equal to 0. Now from this equation, d of P1 plus P2 by dt equal to 0. So this is what commonly I have taken this P1 P2 what outside. So d by dt is common. D by dt is common. P and P2 taken separately. So P1 plus P2 equal to 0. This is what we are saying. Total linear momentum. Consider total linear momentum is constant vector, 0 constant vector. So this is what from Newton's second law we are proving the total linear momentum. P1 plus P2 is equal to 0. So the here one law is given. P1 means the particle. What the P1 is the momentum of particle P1 which apply the force 1 on 2. That is what. So always remember that two particles is interacting, the particle 1 and particle 2 is there. Particle 1 which is exerting a force 1 to on another particle 2. The same time this particle 2 also exerting a force 1 what particle 1 P1 and P2 what particle 1 particle 2. So finally, so based on that we are using a formula F21, Newton's second law. F21 is equal to minus F12. So here in terms of linear momentum we have to write dP1 by dt. So the same thing dP2 by dt you can write down. Then substitute these two in one. From this water d by dt you can take it commonly outside. So P1 plus what will get P1 plus P2. So this is water P1 plus P2 is equal to 0. So it is a constant vector. Now based on this there is a law. If there are no external force acting on the system, then what will happen? Then always this the momentum becomes constant vector. The linear momentum becomes constant vector if there are no external force acting on the system. Assume that P1 and P2 is there. So in these two systems, what will happen? Always the linear momentum, total linear momentum will be 0. If no external force, no force is applied, only the force, these two forces applying. For example, what we can tell is, this two particle is hitting. When this two particle is hitting each other, the conservation, the linear momentum P1 plus P2 is equal to 0. Suppose another one particle is coming and hitting. This is what? No, this is an external force. If no external force is acting on this system, then what the total linear momentum of the system is always constant vector. You can see in page number 131 there is a law. There are no external force acting on, in italics it is given. If there are no external force acting on the system, then what will be? What will happen? The total linear momentum acting on the system is a constant vector, or in other words you can say the total linear momentum of the system is conserved. Conserved means what? Conserved means it is given. It can vary from one to other. That is what here one law is there. Page number 131. It is very important, very important question. This 5-mark question. Not only this, along with this one example you have to write. You can write the best example in page number 132. Shooting, firing example. You all have the practice. You all have seen in many places, in many movies, and in some games also, shootings. Here, assume that a gun is firing. During this firing case, gun is there, bullet is there. So gun plus bullet, that is one system. You can see in page number 132 example. Along with this derivation and the sentences, you have to write this example also. Consider a firing of a gun. We are taking an example, firing of a gun. In that gun and bullet, gun plus bullet is a system. You know this thing, before gun is one system, one particle we can consider P1, and bullet P2 you can consider. So gun and bullet is one system. In this, before firing, this gun is at rest. So gun is at rest means what? The total linear momentum in this system initially at rest. This is what? So P1 plus P2, total linear momentum, what will get? P1 is equal to 0, P2 equal to 0. This is what? Initially, this all is at rest. So the total linear momentum acting on the system, gun plus bullet system, is what? 0. Now, assume that so what we can tell is P1 plus P2 equal to 0. This is what initially happening when the gun is at rest before firing. Now you know that once the gun is fired, what will happen? You know that gun is fired. Gun means a particle 1. So P1 is changing to P1 dash. Remember, listen here. Once the gun is fired, what the system? P1 is changed to P1 dash, as well as P2 is changed to P2 dash. This is happening. Why this is happening? You see, once the gun is fired, a bullet moves forward direction. The gun moves forward direction. Gun moves forward direction means the momentum is changing. So the momentum from particle 1 changing to what? Particle 1 dash. You keep it as 1 dash. 1 new particle. Now here law of conservation of momentum says what? If there is no external force, it should be 0. It should be constant vector. So for maintaining this, what will happen? The bullet also, when the bullet means what? The particle 2. Bullet 2, maintaining this angular momentum, law of conservation of linear momentum, this P2 also changes to P2 dash. Now the total linear momentum is conserved. That is what you can see when the gun is fired, the gun moves forward direction. The gun moves forward direction, but once the bullet goes out, the gun again it move backward direction. That is what gun moving forward direction P1 to P1 dash. When the bullet goes out, it push the gun in backward direction. That is what P2 to P2 dash. Now the total, but in opposite direction. That is what we can tell. This same thing. What F21 is equal to minus F12. This is what we can tell. So this is what. So we say minus P2 we can tell. Instead of this we can use what? Minus P2. Minus P2 means now the gun is, once we fired, the gun move forward direction. The bullet, because of the bullet force, the force from the gun making this gun to move forward, but the force which is producing on this bullet, which is making this gun to move backward direction. So we can tell that during this momentum P1 equal to minus P2 we can tell. So the total linear momentum is P1 plus P2 equal to 0. This is what? So here linear momentum is conserved. It is one of the very best example. This is what we are saying, recoil moment. Recoil momentum. In page number 132, this best example is there. So remember, from here, first assume that two particles interact with each other. When these particles interact with each other, one particle exerting a force on the another particle. Due to that, that particle moves. So particle 1 is exerting a force on particle 2. At the same time, particle 2 exerting a force on particle 1. So we can write this according to Newton's second law. F21 is equal to minus F12 in terms of linear momentum equation. dp P1 by dt. We can write this in terms of linear momentum. Then substitute these two in 1. So what will come? dp2 by d2. This equation derivation, you will get the sum mark. Then writings, then the law. After that, you have to write the example, gun example. So 5 mark question, very very important 5 mark question, which previously asked many exams. So dp1 you can rearrange and write. So dp1 by dt equal to minus dp2 by dt. So take this another side. So dp1 by dt plus dp2. Now you can take this d by dt common. So p1 plus p2 is equal to 0. This is what a law of conservation of total linear momentum. P1 plus p2 is equal to 0. total linear momentum is conserved. Then you have to write the law. What if there are no external forces acting on the system, the total linear momentum is always constant, the vector. In other words, you can say what the total linear momentum of the system is conserved in time. Here conserved means what? It can vary, P1 and P2 can vary. But what vary also, what will get finally? Finally P1 and plus P2 will be 0, constant vector. It is the law, you can mark in page number 131. Then you have to write on example in page number 132 on examples given, firing example. So in that example, you can consider firing the gun. When we fire the gun, what here gun is there, bullet is there, this is our system. Here the system is gun plus bullet. Initially the gun is at rest. When the gun is at rest, what the total linear momentum is conserved. So P1 plus P2 is equal to what will happen? P1 plus P2 equal to 0. Now once the gun is fired, what will happen? Now the linear particle one changes to what? One new particle. When the gun fired, it moves forward. That means the momentum changes from P1 to P1 dash. So to maintain this law of conservation of linear momentum, gun which is moving backward, it is due to the bullet particle 2, but in the opposite direction. So we can write minus P2. So P1 is equal to minus P2. Still P1. If you are taking this minus P2 this side, P1 plus P2 equal to 0. So again total momentum is conserved. This is what we are saying, recoil momentum. So my dear students, it is one of the very important question. Today you have seen Lami's theorem, very important 3-mark question, and this one, law of conservation of linear momentum with the example, recoil momentum example. So this is on 5-mark question. So this is, you have to take this as your homework. Sit in your home, write in notebook, practice it, and see you all. Bye bye. Thank you.